Okay, so in this video, I want to do Leetcode 70 called Climbing Stairs. But the catch here is that I'm only going to show you the DP, the true DP solution. So if you want like a full 20-minute exhibition of this exercise, which goes through everything, you should definitely check out Leetcode's video. He has like the best explanation ever of this problem. Because usually how you solve this problem is that you first start with a depth first search. You basically draw out the whole tree of all the possibilities, and then you look, okay, where am I satisfied with the final, like what are all the paths that I can take towards the final result? Then once you have that solution, you probably realize that there's a lot of duplicate work. So then you go to memoization, where you basically say, okay, in this tree structure that I have, we do a lot of repeated work. So here we have one subproblem, but this subproblem is exactly the same as this subproblem. And this subproblem is exactly the same as another subproblem. And then you talk about, okay, how can I cache the intermediate results so that I don't do any duplicate work? And then finally, you end up at the true DP solution, which is also called the bottoms-up solution, where you use recursion to get the final answer. And in this video, I'm just going to show you the bottoms-up DP approach because this video by Leetcode is so good, and I'm not going to repeat it. So if you want the full solution, just visit this video. Now, let's read the exercise. So you are climbing a staircase, and it takes n steps to reach the top. Each time you can climb either 1 or 2 steps. In how many distinct ways can you climb to the top? So let's go through a simple example first. So if we are at 3, then we are already at the top. So how can we get there? Only one way. If we are here, then it takes 1 step for us to reach the top, plus any steps from here, but that's 1. If we are here, then it takes us 1 step to reach step 2, or we can take a big step from step 1 because we can make 2 steps. If we are at 0, we can make 1 step to end up in 1, or we can make a big step to go to step 2, of course. So let's actually count all these ways. So we can go here. So we can, for example, make like 1 step, 1 step, 1 step. So that's 1. We can make a big step and then make a small step. That's 2. Or we can make we can make a small step and then a big step. So that's 3. But now you see that all these solutions depend on each other, right? So if we are in, say, if we are here, then we are done. But if we are here, we can jump like 1 step to this one, of which we know the solution. And if you are here, we can jump 1 step and then use this solution to get the final solution. Or from here, we take 2 steps, we get here, we use this solution to get to the final solution. So what's the deal? If we are in 3, how many ways can we reach the top? That's only 1. If we are in step 2, how many ways can we reach the top? Also just 1, because we can only make 1 step to the top. If we are in step 1, how many ways can we reach the top? Well, now it's going to be interesting because we can go from 1, we can go to the second one, for which we know this answer, or we can jump immediately to the top, which is this one. So all we have to do is add these 2 together, which gives us a final number of 2. Similarly, for this one at 0, we can make 1 step and then use a solution from 2, or we can get 2 steps and use a solution from 2, which is 1. So again, here we only have to add these 2 together, which gives us a number of 3. And this is the pattern that's going to repeat itself. And then the final answer, of course, is the amount of ways we can reach the top starting from 1. Now, if n, in this case, n is 3, so we need to initialize an array called with n plus 1. And let's do that. So let's make a new array called dp, and we're just going to fill it with zeros. And how many zeros? N plus 1 zeros. Then we need to set the base case, which is the 1 here and the 1 here. So the n and the n minus 1 elements need to be 0. So dp n is 1, dp n minus 1 is also 1. Now we're going to iterate for n, n-1, n-2 until the beginning. And then we're going to add the next two numbers together. So we're going to say for n in range n-2, -1, -1. Then we say dp n equals dp n plus 1 plus dp n plus 2. And then so let's try printing dp. Let's see what happens. Yeah, so n is 2, and then indeed we just have to take the first element. So we say, okay, now all we have to do is return dp0. This should give us the required result. Let's submit it, and there you go. You don't actually need to initialize this array, but I do think it makes it a bit clearer. So thanks for watching.